Today we will discuss about the electric field due to the line charge. Consider a wire which carries the charge, let's say positive charge, and the total charge on the wire is Q total, and suppose the length of the wire is L, then the total charge divided by the total length of the wire, we will call it as rho L, and this is applicable only if the wire is carrying uniform charge, wire is having uniform charge distribution. Okay, distribution. Suppose if the wire is not having the uniform charge distribution, then the rho L, then if it is not non-uniform, then it will be a function of x, y, z, or rho L may be the function of rho, phi, z, etc. Okay, so we will consider now a wire which is of length L, and how much electric field it may produce at some point x, y, z. Okay, suppose you have a wire of length L and it contains charges, maybe positive or negative, whatever. Then at some point x, y, z, how much electric field it will produce. Okay, so this is what, and we will consider it as the uniform distribution. What is that? Uniform charge distribution. Okay, now let us consider the coordinates. Let's say x, y, and z. Okay, and we will consider a wire which is of length L, or we can say it starts from some point z dash is equal to a and z dash is equal to b, because I am considering the integration variable in future as z dash instead of z. Okay, now you see here this is of small length, we will call this length as dz. So at this small length dz there will be some charge, we will call rho L. Okay, because the line charge distribution is rho L, it is nothing but the charge per unit length. Okay, so rho L. So if the charge per unit length is known, then we can see then we can see that for this small differential length dz dash, we get some charge which is nothing but dq, which is nothing but rho L into dz dash. Okay, so this is the charge at this small along the small length, differential length dz. So we have along the differential length dz, we have the charge dq which is equal to rho L into dz. Okay, so I will show it on the left side. It is nothing but dq, it is nothing but rho L into dz dash. Now at some point maybe here, let's say x, y, z, we are going to find the electric field. Okay, now we will see electric field from this point z dash will be pointing like this, right? Because according to the Coulomb's law, the direction of the force will be along the line joining these two charges, because since we are considering a small differential length, we can assume that it is a point charge. Now assume that this can be also represented, this point also can be represented by using the cylindrical coordinate, and it is more convenient for finding the total effect using the integration. Let's say this is rho phi and z. Now in such a situation, we see here this point is z. Okay, and the distance from the z axis is nothing but the radial distance, it is nothing but the rho, and my point where I am going to consider, that means this point is nothing but 0, 0, z dash. Okay, now I can find the vector which is connecting the point number 1 and the point number 2, that means this point and this point. It is nothing but the vector r. So I can write the vector r as I can write the vector r. Actually, yeah, sorry, this point is nothing but, I can consider like this. It is, the radial distance is 0 and it is in the same direction, that means to the point xyz, so phi and z dash. So r is equal to the point 2 minus point 1. This is point 2 and this is my point 1. So 2 minus 1 is nothing but your r. So rho minus 0 is rho, then phi minus 0 is phi, then it's nothing but z minus z dash. So r is equal to rho into a rho plus z minus z dash into az. Now you see the variable z dash, at this z dash, this is the vector r. Now we want to calculate the electric field due to the differential length at z dash. It is nothing but 1 over 4 pi epsilon 0 into the small charge dq divided into vector r divided by the magnitude of vector r, the whole cube, okay, according to the Coulomb's law. Now dq can be replaced as discussed. It is nothing but rho l into dz. So it is nothing but rho l into dz dash, okay, because z dash is the variable. If I want to find the total electric field, then z dash changes from a to b, and I have to do the same thing here. Z dash changes from a to b by using the integration. So this is the total electric field. Now you see, if the wire is infinite length, then the z dash is changing from a to b, then the a will go from minus infinity to infinity, and we want to avoid this kind of integration. So in order to tackle these issues, you see, we will consider the points, the starting points a and b to the point 2 as just shown now. Now you see, the angle from my line rho is nothing but alpha, and this angle we will call, you see, this is to the point b, so we will call alpha 2, and this line, that means from rho to, from the line from the rho to the z dash, the line which is joining the a and the point 2 is nothing but it is nothing but alpha 1. So my integration now, it will changes like alpha 1 to alpha 2, okay, 1 over 4 pi epsilon 0 rho l into dz dash into vector r divided by the magnitude of vector r, the whole cube. But you see, we have dz here. Since we are changing from z to in terms of alpha 1 and alpha 2, we have to find what is the proper differential in term instead of z dash. Now so we are going to replace this, okay. What we are doing now, we will see this length is nothing but, you see, this point is z and this point is z dash, so it is nothing but z minus z dash. So if you consider this triangle which is having rho z minus z dash, and this angle is alpha, then the tan alpha is equal to z minus z dash divided by rho, which implies z minus z dash is equal to rho tan alpha, and also dz dash minus of dz dash, because we are taking the differentiation with respect to z dash, so this become rho into 6 square alpha, or we can say dz dash is nothing but minus rho into 6 square alpha. So what we are going to do is, here I am going to replace this z dash with this value, okay. So minus rho into 6 square alpha into d alpha, because we have to differentiate with respect to alpha also. So now my electric field is equal to 1 over 4 pi epsilon 0, alpha changes from alpha 1 to alpha 2, then rho L, right, into minus rho, then what has happened? Yeah, then 6 square alpha d alpha into rho into a rho, because my vector r is nothing but rho into a rho into z minus z dash into az. But what is z minus z dash? Z minus z dash is nothing but, we have already seen, z minus z dash is nothing but rho into tan alpha. So we will see plus rho into tan alpha into az divided by the magnitude of vector r whole cube. That means rho square plus rho square tan square alpha the whole power 3 by 2. Now this is equal to 1 over 4 pi epsilon 0. Alpha varies from alpha 1 to alpha 2 minus rho L. Okay, these are all constants, so minus rho L into rho. Okay, now you see this become 6 square alpha d alpha, and the denominator is nothing but, this will become rho square into 1 plus tan square alpha the whole power 3 by 2. This become rho cube sec cube alpha, right, because this part will be nothing but sec square alpha. So we will get it as rho cube sec cube alpha. Okay, then what is remaining? Rho a rho plus rho tan alpha az. And you see, you can take this alpha, this is, you can take it outside, and you have one, sorry, not alpha, it is rho, you have one rho here and rho here, and you can take it outside, and also you have another rho here, so rho into rho become rho square. Okay, rho into rho become rho square, and you can delete this. Okay, now what happens here? Sec square and sec cube, and you have a rho square and rho cube, so this will become minus rho L into rho divided by 4 pi epsilon 0. Alpha changes from alpha 1 to alpha 2, and this become 1 over sec, and here it become, you see, 1 over sec. That means 1 over sec is cosine alpha, so this become cosine alpha. Then you have to multiply with a rho plus tan alpha is sine alpha by cosine alpha into az, then you have d alpha. Okay, now this will become minus rho L into rho by 4 pi epsilon 0 integral alpha 1 to alpha 2 cosine alpha a rho plus sine alpha az with respect to d alpha. So this will become, okay, I will use the next page actually. So this will become electric field is equal to minus rho L then into rho divided by 4 pi epsilon 0. Then you see integral of cosine alpha is sine alpha into a rho plus, yeah, integral of sine alpha is minus cosine alpha, so this will become minus cosine alpha into az, then alpha changes from alpha 1 to alpha 2. Now so this will become rho L into rho, and there is a minus sign, 4 pi epsilon 0. You see sine of alpha 2 minus sine of alpha 1 after applying the limit into a rho minus cosine of alpha 2 minus cosine of alpha 1 into az, right? So this is the final answer. So I hope it is clear to you. Okay, I have made a mistake here. You see this what I have considered here, it is row cube and this is row square, and I have written here it is multiplied with the row. It is not like that. It should be the division with the row. Okay, so this should be edited. It should be division with the row. Then this also should be division with the row. This also should be division with the row. So the final answer for the electric field is like this. Now we will consider a special case which is nothing but infinite lengths. That means a wire with infinite length wire, or we can say a wire of infinite length. Okay, that means we consider x, y and z, and we have considered like this a wire of length L, and suppose my point is here, let's x, y, z. You know that this is my ankle. Okay, I will just show only the point at z dash. So at z dash, this is my rho and this is my angle alpha. Now suppose my point B and A is as shown here. Suppose B tends to infinity and A tends to minus infinity. In such a situation, wire will become infinite length. Okay, so in such a situation, you see here alpha 1, that means this is the point actually we have shown as alpha 2. Then what will happen to alpha 2, and also this is alpha 1. So what will happen to alpha 2? Alpha 2 will be equal to, or we can say it will tends to minus 90 degrees. Okay, because you have to view like this, you have to view the point like this. So finally it will go it will increase and finally it will become 90 degrees. And what will happen to the alpha 1? If A is at minus infinity, alpha 1 will be approximately equal to 90 degrees. So we will substitute in the equation 1. So this will become electric field is equal to minus rho L by 4 pi epsilon 0 into rho sine of minus 90 is minus 1 minus sine of 90 is again sine of 90 is 1, so minus 1 minus 1, then into a rho plus cosine of alpha 2 becomes 0 because cosine of minus 90 is 0 and cosine of 90 is also 0, and into AZ. Okay, so this will become minus rho L by 2 pi epsilon 0 into rho, not 2 pi, 4 pi epsilon 0 into rho into minus 2. So final answer will be electric field will be equal to rho L by 2 pi epsilon 0 into rho, isn't it? That is, and also the direction is arrow. So you see here the z component vanish. It is because you see, if you take the infinite length wire and you take the point here x, y, z, then you will have some components which is going up, and you have some component, okay, you have some components which is going like this, going down. That means if you split these components into two, you have some components in AZ direction, and if you are splitting the second one, this one, then you have some components in this direction and also in this direction, in minus az direction. So what will happen to these two components? This is az and minus az will cancel each other, and you will be getting this component as a rho, which is the vectorial sum of this guy and this guy, which will add to form a rho. So this is going to happen. So finally you will be getting an equation like this. Okay, I hope it is clear to you. Thank you.